So welcome to the fourth and final video in the vector component of the mechanics course, the video you've all been waiting for, vector algebra. So before we begin, I'd just like to say that I have noticed in my classes, when I start to use the terms algebra and calculus, I start to see a lot of worried looking faces appearing. And so while there are very definitely parts of algebra and calculus that are incredibly difficult and definitely best left to professionals, there are equally certainly parts that you use and deal with on a daily basis without even thinking. So in this video we will be looking at basic vector algebra and in particular at the addition and subtraction of vectors. So hopefully that sounds a little bit nicer when it's phrased like that. And why do we need vector algebra? So vector algebra is a necessary part of any profession that involves moving things in less than ideal conditions. So pretty much most of engineering and physics. So as an example, if you take a Formula 1 engineer, they're designing the car or their car part to be as aerodynamically efficient as possible. But to do that, they also need to take into account things like friction and air resistance. And when they're doing that, they're dealing with vector algebra. So if we start with our addition, we have our very familiar two-dimensional vector r, equal in this case to 3i plus 4j, and we want to add to it another two-dimensional vector q equal to 4i plus 2j. So to do this, it's very similar to adding numbers. We start with our first vector and we add our second vector, starting where the first one finishes. So it's commonly explained that you take the tail of the second vector and add it to the head of the first. Our resultant vector, or our solution, is just the total. So it goes from the very start of the first vector to the end of the last vector. In this case, from the start of R to the end of Q. And we can see here, so our resultant vector, our answer P, it's just another two-dimensional vector. So we can just write it as we would any two-dimensional vector as the sum of each of its components. So Px plus Py. And we can see from our graph that Px is just equal to Rx plus Qx, and Py is equal to Ry plus Qy. So this equation, or this method, is valid for any number of two-dimensional vectors. So here we only have two vectors, so we only have two x components and two y components. But in the event that we were adding 5, 6, 7 vectors, all we would need to do would be to add each vector component individually. So say we would have the sum of the 6 x components in the I direction plus the sum of the 6 y components in the j direction. In this case, if we read straight off the graph, we can see that our final vector, our resultant, is equal to 7i plus 6j. So in the case of subtraction, we do a very similar thing. So here, instead of addition, we're doing subtraction, but we know that r minus q can also be written as r plus negative q. So in this case, we're just doing the same vector addition, but instead of adding the positive q, we're now adding the negative q. And we follow exactly the same procedure. So we start with our vector r, and where r ends, we start our vector q, or minus q in this case, and our resultant vector goes from the very start to the very end. So r minus q in this case, we follow it's the same, so we do each component individually. So first we subtract our f components, so rx minus qx, and then we subtract our y components, ry minus qy. And again, this formula is valid for any number of vectors. If we take our values from our graph, we have our x value is equal to positive 3 minus 4, and our y value is equal to 4 minus 2. And we find that we have our final vector equal to minus I plus 2j. And we can see from the graph that that matches, like the vector matches the answer, which is always handy. So that concludes our adventure into vector algebra. And on the next page you will find the summary table or summary sheet with all of the relevant definitions and equations, as well as the tutorial questions and solutions. I'd just like to add, if you have any questions or suggestions for this set of videos, please feel free to leave them in the comment section and I will get to them as soon as I can.